In the vast expanse of the Pacific, a new weapon of war took to the skies. It was a machine of unprecedented power and complexity, a technological marvel born from the crucible of conflict. The Boeing B-29 Superfortress, faster, higher, and carrying a heavier payload than any bomber before it. It was designed to take the fight to the very heart of the Japanese Empire. From the firebombing of Tokyo to the world-altering missions over Hiroshima and Nagasaki, the B-29 became a symbol of both devastating destruction and the ultimate price of victory. This is the story of the aircraft that changed the course of history, the men who flew it, and the legacy it left on the world. Air power ended the Pacific War in a way beyond the imagination of any visionary pre-war strategists. None of the Japanese or American planning had been conducted with any idea of the two weapons that would bring the wars so completely and so suddenly to an end: the Boeing Superfortress and the atomic bomb. Conventional air power had gone a long way toward defeating the Japanese, but they were determined to resist an invasion with every weapon at their disposal. The Japanese were a homogeneous nation, 100 million strong. They were willing to die for their country and for their emperor. For the Allies, ending the war meant breaking not just an army, but the spirit of a people. The Boeing B-29 was the most expensive single project of World War II. It cost more than $3 billion for design, development, production, and deployment. The Manhattan Project, which resulted in the atomic bomb, cost $2 billion. The B-29 was clearly the most outstanding bomber in the war by any standard of performance. It was far ahead of the American B-17 and the British Lancaster. The Superfortress was the joint project of a few visionary Army Air Corps planners. They were aided by General Hap Arnold, who pushed the program through in spite of many hazards. The other important factor was the engineering strength and heavy bomber experience of the Boeing Aircraft Corporation. This expertise was becoming critically important as across the Atlantic, the German Luftwaffe's powerful bomber fleet was threatening to pave the way for an invasion of Britain. By 1940, it seemed possible that England would be invaded and occupied. That meant that Nazi Germany would have to be bombed from U.S. bases. The Air Corps called for a speed of 400 miles an hour, a range of 5,333 miles, and a 2,000-pound bomb load. It was an audacious gamble on the part of the Air Corps and of the Boeing Company. Boeing was perhaps taking the greater chance. The Air Corps could hedge its bets with other manufacturers for less ambitious airplanes. But Boeing had to rely not only on its own capability. It also had to trust its vendors. Many of them were being asked to create components fully as advanced as the aircraft itself. Shortcuts had to be taken. Each one added to an already ambitious program. Dollars were freely available, but they were not always a solution. The handsome streamlined airframe was a radical departure from all previous Boeing practice and involved new metals and new fabrication techniques. High-strength aluminum alloys were used extensively, and its massive components were joined with flush riveting to create a strong, aerodynamically clean skin, essential for achieving its unprecedented speed and range. Boeing's entire production capacity was occupied with building the B-17. For the B-29, it was necessary to build entire new plants, and there was a greater challenge: the creation of a new, highly skilled workforce. Vast schools were established on the factory sites with 90 days of training or less. Farmers, housewives, and young people just out of high school were taught how to do everything necessary to build the most complex aircraft in history. By 1943, Boeing had 58,000 employees building the B-29. Boeing knew from the start that its greatest question mark was the unproven engine. The R-3350 needed several more years of development than was available. It would go into the field unready. It would be a constant nightmare to mechanics and a worry to pilots taking off with too heavy loads from too short runways. Even with the R-3350's power, the speed and range requirements were too difficult to attain. They could only be achieved by combining a highly streamlined design with a wing using a new Boeing high-lift airfoil and a sophisticated flap system. The USAAF thought Boeing's approach was too radical. They thought the wing loading was too high and that their pilots wouldn't be able to handle the airplane. They cited the experience of the cantankerous Martin B-26 as an example. Boeing analyzed the B-26 and found that it had a low aspect ratio wing mounted on the fuselage in a way that induced drag. They explained that the B-26's problem stemmed from bad design. They said that the B-29's excellent design would avoid difficulties. To achieve the necessary performance, the B-29 had to operate at high altitudes. For this, pressurization of the fuselage was mandatory. Boeing had experimented with pressurization in the Model 307 Stratoliner passenger plane, but no production bomber had ever been pressurized. The B-29 adopted a new three-bubble system. The pilot, co-pilot, engineer, radio operator, and navigator were up in the front pod. The gunners were positioned in the mid-fuselage pressurized area and connected to the cockpit by a tunnel spanning the twin bomb bays. The tail gunner was crammed into a third pressurized compartment in the rear, isolated and very much alone. Because of the pressurization system, standard gun turrets could not be used. The armament had to be remotely operated. A General Electric fire control system had to be created. It used an early computer that compensated for speed, range, altitude, wind, temperature, and trajectory. The results were remarkably good. Any gunner, except for the tail gunner, could control more than one station. The computers permitted firing at targets beyond the range of conventional hand-operated guns. The demand for the Boeing B-29 increased, and rival firms like Bell and Martin were brought in to meet production needs. Bell Aircraft and the Glenn L. Martin Company were tasked to build it. Boeing felt it was being asked to train competition for the post-war marketplace, and the government essentially forced them to share every blueprint and manufacturing secret in a program of unprecedented industrial scale. The USAAF had placed a mammoth order for 1,664 of the aircraft. This was an incredible gamble, committing billions of dollars to a plane that had yet to prove it could fly reliably. But the first two prototypes caught fire in the air. The second one crashed into a meatpacking plant and the entire crew was killed. In spite of all the difficulties, the first B-29 of the 58th Bombardment Wing landed at Kharagpur, India on April 24, 1944 to begin Operation Matterhorn, which was designed to knock out the Japanese steel industry. The idea of B-29s bombing Japan from Chinese bases was attractive in political terms. President Roosevelt had promised Chiang Kai-shek to begin bombing operations against Japan by November 1944. But in practice, the plan was flawed for a wide variety of economic, logistic, and command reasons. Chiang Kai-shek's subordinates refused to get serious about building air bases until enough money had been paid to permit embezzlement on a massive scale. Army General Vinegar Joe Stilwell estimated that at least half of the $100 million in gold required by the Chinese was siphoned off to corrupt officials. The air bases themselves were a monument to the patience and industry of the Chinese people. They literally built them by hand, without power equipment of any sort, using the most primitive tools to move earth or chip stones. The operation was based on the assumption that the V-29s would support their own operations by flying gasoline over the hump, the high mountain passes of the Himalayas separating India and China. The B-29s would be supported by a fleet of B-24s serving as tankers. But the B-29 was a brand new weapon that had not yet received sufficient testing and it would be bad practice to subject it to continuous flights over the mountains. Then there was the primitive maintenance and the continuing shortage of parts and labor. But the task had to be done. There was no alternative. The complexity of the logistics was a function of the sheer size of the B-29 units. The Superfortress had a crew of 11. 7 aircraft were assigned per squadron, with 28 per group, and a grand total of 112 year for the wing. Each B-29 was assigned 2 crews. A fully manned wing had a total of 11,112 personnel. When all its elements arrived overseas, the 20th Bomber Command had more than 20,000 officers and men plucked down in brand new bases in India and China, eager to go to war. Lieutenant General George Stratemeyer was made responsible for the 20th Bomber Command's administration, while General Claire Chennault handled fighter defense and ground support for the B-29 bases in China. This created immediate friction, as both had to draw from the same trickle of supplies being flown over the treacherous Himalayan mountains, an airlift known as the Hump. The B-29's first combat raid was mounted on June 5, 1944, as 98 aircraft targeted the railroad yards in Bangkok, Thailand. This was essentially a full-dress rehearsal, but the results were sobering. 5 bombers were lost, not to enemy action, but to engine fires and mechanical failures, highlighting the steep learning curve ahead for the revolutionary new bomber. 5 aircraft crashed en route, and 42 had to make emergency landings. Later reconnaissance revealed that fewer than 20 bombs had landed in the target area. It was not a good start for the $3 billion program. The commanders were veterans of the European theater, and were not yet aware of how different the B-29 was from the B-17. Nor were they aware of how difficult the Japanese targets, geography, and weather were compared to Germany. Hap Arnold demanded better results. He wanted an attack on the Japanese homeland. On June 15th, Wolfe launched 92 B-29s from India. Of these, only 79 reached their Chinese staging bases. 78 were dispatched on a night raid against the steel mills of Yawata in Kyushu, Japan. Each plane carried 2 tons of bombs. The results were once again disappointing. Only 47 aircraft made it to Yawata. Only 1 bomb hit the target. It damaged a power station more than half a mile from the steel mill's coke ovens. The Americans took comfort in the damage they must have caused to Japanese morale. But Arnold was not after Japanese morale. He was after their industry. The story of the next 6 months was much the same. And at home in the U.S., there was a myriad of B-29 production problems. Wolfe was sent back to sort them out. In September, the 20th Bomber Command was taken over by a firebrand from Europe. His name was Curtis LeMay. The dramatic acceleration of the Pacific War permitted a 2-pronged strategy of attack. From bases in Chengdu, China, the 1,600-mile operating radius of the B-29 permitted it to hit targets from Manchuria through Japan all the way down to the tip of French Indochina. Superfortresses operating from Saipan and the Marianas could cover all the important targets in the heartland of Japan. Curtis LeMay's 20th Bomber Command was the first of 2 prongs. To provide the second, the 21st Bomber Command was established in November 1944. It was to operate out of new airfields in the Mariana Islands. One of the United States Army Air Force's great planners, Haywood Possum Hansel, was made commanding officer of the 21st. Hansel landed his B-29 Jolton Josie, the Pacific Pioneer, on Saipan on October 12, 1944. He was eager to validate in battle the many plans he had helped create. Hansel felt the weight of his responsibility. He knew that even Curtis LeMay, in spite of his success in Europe, was having trouble turning things around against the Japanese in China. Occasionally, good bombing results were obtained, but every single mission remained a dangerous gamble against both the enemy and the aircraft itself. In April 1945, the assets of the 20th Bomber Command would be transferred to Tinian and Guam. By then it had failed in its essential task of sustained bombing of Japan. So much had been expected of the B-29 that the American commanders were driven to prove that it was in fact an excellent weapon. At the very highest levels of command, where people were aware of the Manhattan Project, the urgency was even greater. Only the B-29 could carry the atomic bomb. If the Superfortress failed, the Manhattan Project would become a complete waste. The pressure was felt and transmitted, but in the months after his arrival on Saipan with the 21st, Hansel was able to do no better than had previously been done in the 20th from China. The Committee of Operations Analysts had reconsidered the priorities in Japan. They now suggested that the aviation industry was the most important target. This had been the Air Force's choice all along. The Joint Chiefs of Staff directed that the principal aircraft engine manufacturers around Tokyo become the primary targets. The long series of attacks on Tokyo would be helped by the incredible bravery and skill of the crew of an F-13, the unarmed reconnaissance version of the Superfortress. Early in the morning of November 1st, 1944, Captain Ralph D. Stakely's F-13, a stripped-down, unarmed photo reconnaissance version of the B-29, became the first U.S. plane to fly over Tokyo since the Doolittle raid over 2 years earlier. For 35 minutes, their cameras methodically captured over 7,000 images. These priceless photos became the basis for all subsequent U.S. attacks on the city. Hansel's first strike on Tokyo was to be called San Antonio 1. After much training and many postponements, San Antonio 1 began at 6:15 a.m. on November 24th. The first plane to roll down Isley Field's runway was Dauntless Dottie, flown by Brigadier General Roscoe Rosie O'Donnell. His co-pilot, Major Robert K. Morgan, had been a pilot on the famous B-17 Memphis Belle. Dauntless Dottie was followed by 110 more B-29s, carrying 278 tons of bombs. But the promising start to the mission unraveled. 17 aircraft aborted. 6 more found themselves unable to bomb for mechanical reasons. The rest were caught up in a 120-knot wind. It was the infamous jet stream, then only just being recognized. They were swept over the target at a blistering 445 miles per hour, too fast for accurate bombing. The sophisticated Norden bomb sight simply couldn't compute a release point at such an extreme ground speed, rendering the advanced bomber effectively blind. On the positive side, Japanese fighter resistance was light and flak was ineffective. Once again, reconnaissance photos showed the bombing results to be totally inadequate. Only 16 bombs had been observed to hit the target area. By now, the B-29 was performing fairly well. Extensive modifications had improved the reliability of its engines, but bombs were still not hitting the targets. Flying at 30,000 feet, crews encountered the unknown fury of the jet stream, hurricane-force winds that scattered their bombs harmlessly across the landscape. The early Japanese analysis was that the costs of the B-29 were so great and its results so negligible that not even a wealthy nation like the United States could afford to persist with the attacks. But unknown to all of the Japanese and most of the Americans, a change was in the wind. On December 18, 1944, 84 B-29s of Curtis LeMay's 20th Bomber Command dropped 500 incendiary bombs in a daylight raid on Hankow, China. The attack destroyed the city as a major Japanese base. General Haywood Hansel's 21st Bomber Command was ordered to switch tactics from high-altitude precision strikes to a large-scale incendiary raid on the city of Nagoya. Hansel, a staunch advocate for the doctrine of precision bombing, fundamentally objected, but the B-29s were consistently failing to hit their targets due to the powerful high-altitude jet stream. And Washington demanded results from its multi-billion-dollar investment. In standing by his principles, he put his career on the skids. You can buck the brass in the military, but only if you succeed. A test raid was run on Nagoya on January 3, 1945. 97 B-29s carried mostly incendiary bombs. It wasn't a good mission. Only 57 aircraft bombed the designated target, and the damage on the ground was slight. Unbeknownst to the American planners, the bombers were flying against the powerful winds of the jet stream, making high-altitude precision bombing nearly impossible. The Japanese, however, drew the conclusion that their fire prevention system was highly efficient. It was an erroneous and eventually disastrous assumption. Hansel reverted to his previous precision bombing tactics, but was unable to generate better results, apart from one successful attack on the Kawasaki aircraft plant near Kobe. The one success didn't help Hansel. If you worked for Hap Arnold, you delivered, or you were relieved. Hansel was relieved by Major General Curtis LeMay. Hansel's forte was planning. The time for planning was past. Now was the time for direct action, which was Curtis LeMay's strength. As a new commander, LeMay received more latitude than Hansel. He made 2 attacks using Hansel's methods. Then he put 69 aircraft over Kobe to drop incendiary bombs. There was heavy fighter opposition. 2 B-29s were lost and 35 were badly damaged. But the city of Kobe was hurt. More than 1,000 buildings were destroyed. In the latter part of the war, America's overwhelming advantage in numbers and quality usually allowed American forces to brush Japanese opposition aside. As the precision bombing efforts continued, further tests were made with incendiary bombs. In a heavy attack on Tokyo on February 25th, almost 30,000 buildings were destroyed. But the precision strikes against Japan continued to be ineffective. Enemy fighter opposition stiffened. In the series of attacks in February, 29 B-29s were lost to fighters. 10 were lost on the long overwater trip between Saipan and Japan. Another 21 crashed because of operational problems, like engine fires, runaway propellers, or fuel exhaustion. And so far, the results were insignificant. The B-29, the multi-billion-dollar bomber, had failed in its intended role. Costing more than the Manhattan Project, a failure of this magnitude was simply not an option for Washington. The loss of 60 bombers in that 1 month alone meant over 600 trained airmen were gone. Morale was plummeting with every costly, ineffective mission. Back in Washington, the head of the Air Forces, General Hap Arnold, knew he had to make a change. He brought in a hard-driving, no-nonsense commander from the European theater, Major General Curtis LeMay. LeMay cared about one thing above all others: results, and he was determined to get them, no matter the cost. But Curtis LeMay already had the remedy in mind. LeMay was aware that he was as vulnerable to Hap Arnold's impatience as any other man. He decided to try tactics he had long considered and which had been carefully tested in the United States. It was the common opinion that Japanese cities were much more vulnerable to firebombing than those of Germany, and although Japanese industry was spread out into residential areas, it was still far more concentrated than its German counterpart. The B-29 had been designed from the start as a high-altitude bomber. In the European theater, it would have had to remain so. But conditions were different in Japan. Anti-aircraft guns and searchlights were not radar-controlled, meaning their defensive fire after dark was wildly inaccurate. It was reported that there were only 2 night fighter units in the homeland. Japanese airborne radar was primitive and not widely used. Without notifying General Arnold, LeMay decided to launch a series of maximum-effort, low-level, incendiary night attacks against Japan. In a shocking move, he ordered the planes stripped of their machine guns to carry more bombs. He was putting his career on the line. Night bombing offered many advantages. The winds were not so strong, the B-29's navigation system operated more efficiently, and flying at a lower altitude eased the strain on the engines. Lowering the fuel consumption and leaving behind armament and ammunition permitted a much bigger bomb load, about 12,000 pounds per plane. The concept of unarmed, low-level night bombing alarmed many of LeMay's staff. The word murder was quietly mentioned, but never to LeMay. The first raid was set for the night of March 9th. 334 B-29s carried almost 2,000 tons of bombs. The aircraft in the lead squadrons were to act as simple pathfinders. Their napalm bombs were intended to start major widespread fires, which would require the mobilization of all the Japanese firefighting equipment. The rest of the B-29s each carried 24 cluster units of M69 incendiary bombs. The M69 was designed by a high-level group of American scientists and engineers, some of whom were also involved in the Manhattan Project. Each M69 was only 20 inches long and 3 inches in diameter. It weighed just over 6 pounds. These bomblets were packed by the hundreds into large cluster bombs that broke apart mid-air, designed to saturate entire city blocks. On crashing through the roof of its target, an M69 was designed to detonate and spew out flaming gel as far as 30 yards. This gel, an early form of napalm, stuck to whatever it hit and burned with hellish intensity. The technology of the M69 and the great logistics needed to deliver it was an expression of the disparity between the American and Japanese war machines in 1945. The Japanese simply had no counter and no equivalent. On the evening of March 9, it took almost 3 hours for LeMay's entire force of B-29s to get airborne. Over 300 bombers launched from the sprawling airfields of Saipan, Tinian, and Guam. An unprecedented stream of silver climbing, one by one, into the vast Pacific night, forming an immense bomber stream for the long flight north to Japan. Over Tokyo, the visibility was 10 miles or better. The napalm bombs of the Pathfinder aircraft started fires that were fanned by a brisk and rising wind. The initial attack targeted a 12-square-mile area of the most densely populated part of the city. The fires spread rapidly, and the results were devastating. The inferno created a firestorm with its own hurricane-force winds, literally boiling the water in the city's canals. The fire services were overwhelmed within 30 minutes of the attack. A firestorm swept the city. More than 250,000 buildings were destroyed. More than a fourth of the city's houses were gone. More than 1 million people were homeless. 83,000 dead and 40,000 injured. The Japanese were horror-stricken. There was no way to comprehend a disaster of this magnitude. It completely overrode the ideas of national superiority, the samurai spirit, and of the nation's place in the sun. Emperor Hirohito himself toured the blackened ruins, a profound sign of the shock that reached the very throne. On March 11th, the city of Nagoya became a target for incendiary attack. There was no firestorm, but 2 square miles of the city were destroyed. Osaka was attacked on March 13. The city was blanketed by cloud cover, and the B-29s were forced to use radar bombing. Unexpectedly, that gave more uniform results than visual bombing. Within 3 hours, more than 8 square miles of the city were totally destroyed. Morale in the B-29 units kept climbing. LeMay had found the magic formula. He made maximum use of the B-29 in tactics that took advantage of the enemy's weakness. These tactics converted the B-29 from a blunder to a war winner. LeMay was on a rampage. He drove his crews hard. They were already flying 60 hours a month, which was higher than the average of the 8th Air Force in Europe. But there was a shortage of replacements, and that shortage forced LeMay to increase monthly combat time to 80 hours. He had the scent of victory in his nostrils, victory over Japan, and victory for the concept of air power. LeMay knew that he had arrived at a point that General Carl Spaatz and Bomber Harris had only dreamed of. He had the ultimate weapon at his disposal, and he knew that there was more to come. He believed that the maximum effort with his command could destroy Japan's ability to wage war. The strength of the 21st Bomber Command grew every day. By April, LeMay had more than 500 aircraft at his disposal. On May 11th, he launched a further attack on the 3 Japanese cities. His goal was to create such havoc that the terrible cost America had borne invading Okinawa would not be repeated in Japan. By June 15, he had destroyed 112 square miles of Tokyo, Nagoya, Kobe, Osaka, Yokohama, and Kawasaki. His bombers now had the benefit of long-range escort fighters, the P-51 Mustangs from Iwo Jima. The bloody battle for that island now paid dividends, allowing a switch back to protected daylight precision raids. This devastating one-two punch of night firebombing and escorted day strikes left Japan's war industry utterly shattered. LeMay had destroyed the 6 principal industrial cities of Japan at a cost of 136 aircraft. The American loss rate of 1.9% was acceptable, but the reality of it was still horrific. Japan was not able to stop this destruction. It lacked the anti-aircraft guns, radar, and fighters to repel the invaders. It lacked fire engines, bomb shelters, and hospitals to help its citizens. Yet Japan was held captive by a martial spirit. That spirit had served the country ill on almost every battlefield in this war, but the government voted to fight on. LeMay and the 21st Bomber Command had brought Japan to its knees, but it would not surrender. The B-29's success in area bombing was a great relief to all those who had staked so much on its development. At the time, few people were aware of the Manhattan Project and the essential role the B-29 would play in the successful delivery of an atomic weapon. By July 1941, the decision had been made to create an atomic bomb before the Germans did. The Manhattan Project eventually employed 120,000 people, including the country's top engineers and scientists. On July 16, 1945, an experimental bomb was detonated with results that were incredible even to those who had created it. Word of the successful test was immediately sent to the new president, Harry S. Truman. Truman, who was a novice, was plunged into the Potsdam Conference with Winston Churchill and Joseph Stalin. Truman mentioned to Stalin that a powerful new weapon had been tested. Stalin responded that he hoped it would be tested to good effect against the Japanese. Truman was pleased that Stalin did not press for more information. He was unaware that Stalin already knew what he needed to know from Soviet spies at the center of the Manhattan Project. The Potsdam Declaration of July 26 indirectly warned the Japanese of the power of a new weapon. It stated that the only alternative to surrender was prompt and utter destruction. Japan was badly wounded by the B-29 raids. It was also cut off from food and industrial imports. Japanese leaders were fully aware that the war was lost, but as yet had not found a way to acknowledge it. a cultural phenomenon emerged that was unfamiliar to the West. It was mokusatsu, a time-honored technique by which a Japanese official would take refuge in a lofty silence when he did not agree with or did not understand an order. When the new Japanese Prime Minister Suzuki announced his response to the Potsdam Declaration, he used the term mokusatsu. He meant to say, in essence, no comment. But his remarks were translated as meaning that Japan was contemptuously ignoring the declaration. It was a fatal error. In early 1944, plans for modifying 15 B-29s were formulated. The modifications were not extensive. The atomic bombs were being designed at the same time. The designs were adapted as much as possible to fit the B-29's bomb bay. The following summer, Arnold authorized a top-secret team of experts to create the first combat unit to use the new weapon. Colonel Paul W. Tibbets, Jr. was selected as commander of the new 509th Composite Group. The remainder of the group was handpicked to ensure they had the best possible people. For a long time, Tibbets was the only person in the 509th to know the true nature of the mission. The special facilities required for handling and loading the bomb were prepared on Tinian in the spring of 1945. By July, the 509th and its specially modified B-29s were in place. Further training began immediately with 6 specialized missions. Some of them involved harassment bombing of isolated garrisons on the islands of Truk and Marcus. After July 20th, the 509th crews executed 38 sorties, gaining experience in the precise tactics to be used when the atomic bomb was dropped. These sorties also made the sight of small formations of B-29s seem customary to the Japanese. A list of target cities was drawn up. They were the largest cities with the least damage remaining in Japan. Kyoto was removed because of its cultural significance and because of the negative reaction in Europe to the bombing of Dresden. Truman and Secretary Stimson felt the destruction of Kyoto might drive Japan into the Russian camp after the war. Hiroshima was now at the head of the list. Later, Nagasaki was added to the list. On Tinian, all necessary elements of the strike were prepared. Field Order No. 13 was signed on August 2, 1945 by Lieutenant General Nathan Twining. It directed the 509th Group to make a visual attack on Hiroshima. At one time, Hiroshima had been a busy naval port, but the port had been mined, and the population was now reduced to under 250,000 people. There were many military installations. The entire economy was geared to the Japanese war effort. There were no Allied prisoner of war camps in the area. Seven aircraft were assigned to the mission. Leading the principal force was Tibbets in the Enola Gay, named after his mother. The Enola Gay was accompanied by 2 escort planes crammed with cameras and observers to record the event. 3 aircraft were assigned duty as weather planes. 1 was designated as a spare. On August 4th, the crews were told the exact nature of the mission and that one of the bombs had the predicted power of 20,000 tons of TNT. But even then they were not told it was an atomic bomb. At 2:45 in the morning of August 6, the Enola Gay took off. Five and a half hours later, Tibbets received word that the weather and visibility were good. At exactly 9:15 a.m., the Enola Gay was flying at 328 miles an hour at 31,600 feet. Bombardier Major Thomas Farabee dropped the bomb. Tibbets then executed what later became known as the breakaway maneuver. a steeply banked 150-degree turn to avoid the expected blast. By the time the bomb exploded 50 seconds later, the Enola Gay was 19 miles away. At detonation, there occurred the fireball, followed by the swiftly rising mass of smoke that turned into the notorious mushroom cloud, the cloud that still casts its symbolic shadow. President Truman immediately announced the event to the world. The news amazed even many members of the 509th Composite Group. The Japanese reaction was confused. Officially, they diminished the results of the attack. They said that it was only a new bomb, which should not be made light of. Certainly not. 4.7 square miles of Hiroshima's center had been obliterated. More than 40,000 buildings were destroyed. Almost 80,000 people were killed. 171,000 were made homeless. LeMay's B-29s and the U.S. Navy's carrier forces maintained pressure against Japan while the sole remaining atomic weapon in the world was prepared for use. The second and last atomic mission of the war began at 3:49 a.m. on August 9th. Major Sweeney and his crew flew Boxcar. They had traded their usual aircraft, the Great Artiste, to the crew of Captain Frederick C. Bach. Sweeney's mission was as troublesome as Tibbitz's mission had been trouble-free. The primary target was Kokura, but it was weathered in. Sweeney made 3 bomb runs, but the bombardier couldn't see the target visually. Some Japanese fighters were in the area. Sweeney diverted to the secondary target, Nagasaki, which was also cloud-covered. Boxcar used radar for its run, and, at the last minute, the bombardier, Captain Kermit Behan, saw the target. At 10:58 a.m., he hit the bomb release. Most people were either at work or at home when the bomb detonated within 1 mile of the 2 huge Mitsubishi arms factories. Nagasaki's bowl-shaped terrain confined the effects of the bomb to a relatively small 1.45 square mile area. Approximately 35,000 people were killed. Incredibly, Emperor Hirohito's advisors on the Supreme Council for the direction of the war still debated whether or not to surrender. As Adolf Hitler had done, the military factions still wanted to resist in hope of obtaining better terms. On August 10th, the Japanese announced not their surrender, but their willingness to accept the Potsdam Declaration. In the days preceding the Japanese statement, routine B-29 missions had continued. On August 11th, they were suspended to give the negotiations a chance to mature. The United States responded to the Japanese statement by advising that from the moment of surrender, the authority of the Emperor and the Japanese government would be subject to the Supreme Commander of the Allied Powers. When no word came back from the Japanese government, LeMay's B-29s were authorized to resume attacks. General Arnold had long awaited his own Tokyo Millennium, 1,000 aircraft over Tokyo, while General Spaatz would have preferred to use the third atomic bomb if one had been available. LeMay was able to meet Arnold's wish. He put up a total of 828 bombers and 186 fighters, over 1,000 aircraft in all, over Tokyo on August 14th. Before the last aircraft had landed, Japan had surrendered. The American forces continued to make a display of their air power over Japan. This reached its highlight on September 2nd, when 462 B-29s cruised over Tokyo Bay, while the surrender was signed aboard the USS Missouri. In the meantime, B-29s had dropped almost 5,000 tons of supplies to more than 63,000 prisoners of war in camps in Japan, China, and Korea. This was the Superfortress, the magnificent, terrible weapon that delivered victory from across the ocean and carried the blinding dawn of the atomic age.
Air Force General Henry Harley Arnold writes in 1941, "A nation likely and able to win a war will enter it not only with the largest and most efficient Air Force, but behind that first line will stand the second line, the ability to maintain that superior strength in men and machines." 3 years later, the general's prophecy is now reality. On June 15, 1944, the first B-29s fly over mainland Japan. Unlike the Doolittle raid 2 years prior, this is a mission of epic proportions. That is because Boeing's Superfortress, the largest plane in the world, is designed for destruction, to grind the Japanese into a pulp, to bring them down to their knees once and for all. With wings spreading over 140 feet, a fuselage 98 feet long, and 4 engines each possessing 2,200 horsepower, the Superfortress is the envy of the entire world. A true symbol of American industrial power. Billions of dollars, combined with the blood, sweat, and tears of its creators, make this the most feared aircraft of the Second World War. For it is a weapon that doesn't start wars, it finishes them. For all its accolades and accomplishments, the Superfortress is America's biggest gamble of the war. A design so complicated, it is the most expensive risk for the United States government. A project that at times seems doomed for failure, and a project that requires a contingency plan. What to do if it never makes it out of the factories? Where to go if the people of Boeing cannot get the job done? This is the secret history behind one of aviation's greatest bombers, and how it almost never came to be. The what-if scenarios that America is prepared to take in order to get it off the ground and win the war raging in the Pacific. This is the race for the Superfortress. Even before America is officially involved in the Second World War, the B-29 is already envisioned. The need for long-range aircraft capable of rendering a decisive blow against any potential enemy is an urgent priority for visionary generals like Hap Arnold. For the next 2.5 years, as America remains officially neutral, they are behind the scenes, making extensive plans that include a barrage of new military projects, with a long-range bomber high on the list. Not until the Japanese attack on Pearl Harbor in December of 1941 do the wheels begin to seriously move.
In the first few weeks of war, over 350 of the 525 combat planes we had in the Pacific area were destroyed. Over 1/4 of our total combat strength was lost. We suddenly found ourselves engaged in a mortal struggle with an enemy who could be counted on for nothing except bitter and fanatic opposition.
According to President Roosevelt, the United States was not particularly well prepared to engage in the war itself. In 1940, Roosevelt called for increased congressional appropriations for military spending, arguing that what the United States needed was to be producing 50,000 planes per year. In 1939, the U.S. produced fewer than 6,000 planes.
With the United States at war against both Japan and Germany, bombers are rushed into service. As one old soldier remarked, "Isn't it sad? During all the years since the First World War, we've had all the time in the world but no money. Now we have all the money in the world but no time." In this race against the clock, America comes together. Bombers are wheeled out of assembly lines in order to wreak havoc over Germany. Of notable distinction are Boeing's Flying Fortress and Consolidated's Liberator, where in Europe, with Britain providing a base for operations, American air power is successful due to the short distance from England to Germany. On the other side of the world, the situation is very different. In the Pacific, aircraft with a greater range are needed in order to attack the heart of Japan. It is this geographical requirement that calls for the construction of a design that not only delivers tremendous firepower, but ensures that it reaches its target there and back safely. Operation Matterhorn, the secret plan to bomb the Japanese from China. Approved by President Roosevelt, it is in these pages that the urgent need for the Superfortress is born.
The initial requirements, simply as I recall them, were a 5,333-mile range, and I don't know why that odd number, a 2,000-pound bomb load, and I think the speed that they specified was something like 273 miles an hour or something. Those were the basic requirements.
A unique organization, the 20th Air Force, is formed, headed personally by Hap Arnold, to see over all B-29 operations. All the military needs now is for one company to step up. Unlike the military-industrial complex of today, during the 1930s, aviation companies are hesitant to get in bed with the government to make military planes.
Companies that could easily be producing military goods, such as aircraft factories, were reluctant to convert their plants for military production because they weren't sure how long hostilities would last.
In an era of neutrality acts and cynicism towards any signs of war profiteering, only fixed-price contracts are given by the United States. Under these rules, the developer must put forth their own money towards the design with no guarantee of a deal being signed. And with technology becoming more complex, signing on to the B-29 is like playing Russian roulette with your company's future. It is a large risk, one that the giants of aviation are not willing to take. As one Boeing employee said, "There was no sound of coin in Uncle Sam's jeans. His pockets only carried marbles and chalk." With most manufacturers losing money during this period, few were willing to step up to the plate.
The military production in which U.S. workers were engaged in 1940 and 41 as part of the effort to support the Allied forces helped to pull the United States out of the Depression. Lots of people were back to work, and what that meant was that they had disposable income. Many manufacturing firms did not want to convert to military production because they were eager to take advantage of that consumer dollar that was now available.
Douglas, a rare company to turn a profit during the Great Depression, is avoiding the super bomber project like the plague. After having their arms bent by the government to develop the B-19, they reported losses of more than $2 million. Not wanting to be fooled again, their submission for the contract is nothing more than a slightly modified version of that same bomber. In government circles, there is great concern. If Douglas is only putting forth a minimal effort, it is apparent that they are not interested. Lockheed, another manufacturer, is still a young company and a question mark at best. Boeing, having lost money on the B-17, would have gone bankrupt had the government not bailed them out in 1940. With only 2,000 employees, they, like others, want to stick with what is known and proven, instead of venturing out into the uncertain. Surprisingly, they submit their design, and it is accepted.
Boeing had a tremendous reputation on the basis of the B-17. And when you think about the Pacific now, it would have been impossible for B-17s and B-24s to fly those distances in the Pacific.
And so the makers of the Flying Fortress begin the project in haste, starting work on a plane that is built before it is even designed. Certain sections of the aircraft are constructed before detailed designs of other parts are even sketched out. They begin a long and painful journey to build one of the greatest airplanes ever. Boeing decides that the B-29's central nervous system is to be based in America's heartland, Wichita, Kansas. A small city of just 120,000 people is chosen as the site where the Superfortress is to be built.
Why Wichita specifically? There are a couple of reasons for this. If you look at a map of the United States, you'll see that Wichita is just about in the dead center of the country. Also, unlike some other cities in the state like Kansas City, Wichita had a very tiny proportion of foreign-born residents. Some government officials were concerned that immigrant workers would be more inclined to participate in labor agitation, might be more inclined to come from a socialist or communist tradition, or in some cases might be allied with Nazism.
Hundreds of miles away from America's vulnerable coasts, and a farming population familiar with machinery requiring less money to live on, Wichita is ideal for Boeing. Expansion is a necessity, and the city is eager to accommodate both the government and Boeing during the war years.
The Great Plains region mobilized to lobby to bring industry to their area. The state of Kansas organized an Industrial Development Commission in 1939, and in fact, the governor of Kansas went to Washington, D.C. to lobby on behalf of his state, arguing that Kansas was safe from invasion. It had lots of natural resources, such as oil, gas, and coal, and it had a large supply of pragmatic farm boys.
And so begins an assembly line of epic proportions. A similar system that Henry Ford used to make Model Ts in Detroit, Boeing is using to make Superfortresses in Wichita. Grandmothers, who never wrestled with anything more intricate than a wood stove up until 2 years ago, are building Superfortresses at Wichita. What is true at Wichita probably applies equally to other major production units of the B-29 program. The Superfortress truly can be said to be a product, as President Lincoln said, of their government. That is, of, by, and for the American people. Quoted from the New York Times. With a small army of workers, over 60% of the aircraft is fabricated on the spot. Unfortunately, one plant cannot do the job alone. The outsourcing of the B-29's many parts are done in cities such as Marietta, Georgia, Omaha, Nebraska, and the home of Boeing, Renton, Washington. It is a project coming from every corner of the country, a true testament of America's industrial strength during the Second World War. As the B-29 is constructed, one notices that it is not revolutionary but evolutionary. A true sign of the times, with militaries thinking bigger is truly better. At the beginning of American war production, the average aircraft weight is estimated to be just over 3,000 pounds. 4 years later, that average is shot up to over 10,000 pounds. With this plane's massive size and potential, it comes as no shock that its supporters are eager to get up in the air as soon as possible. Although the enthusiasm for the B-29 is strong, the call for a plane of this magnitude is easier said than done. Being twice the size of the B-17 and requiring double the horsepower, completing it is no easy task.
It was a big jump from, let's say, the B-17 for people who were in the 17 that went to the 29, and it was one very big jump for us who went from the B-25 to the B-29. It was monstrous.
You had tremendous power in 4 engines compared to the B-17. And I flew the B-29 up to 40,000 feet, whereas the B-17 would barely go to 30,000.
Before being put into production, 10,000 drawings are sketched of a prototype, costing the government over $3 million. With it needing to be rushed only adds to its growing list of future problems. Its main flaw is its complexity. With a need to fly at extremely high altitudes, a pressurized cabin is desired, so its crew are not required to wear masks in the air.
It was the first pressurized airplane, one that I'd ever flown. I think it was the thing after the B-17, the B-24 that came along that had a pressurized cockpit, which made flying at altitude far more comfortable than unpressurized, of course.
You kept your oxygen mask handy just in case you lost your pressurization. But it was very comfortable. It was a big relief, much easing of strenuous activity on the part of the whole crew.
Also, with 4 extremely powerful engines and over 60,000 different pieces needed to assemble just one plane, this project is turning into one giant jigsaw puzzle. In addition, an enormous amount of material needed. 27,000 pounds of aluminum, 5,000 pounds of rubber, 10 miles of wiring, over 1,000 pounds of copper and brass, and nearly 2 miles of tubing are needed to make this monster. To some, this is becoming a case of the United States biting off more than it can chew. Despite the best efforts of its designers, engineers, and workers, the B-29 is encountering numerous problems. For a population of 120,000, putting together a 120,000-pound Superfortress is a massive undertaking due to its workforce's relative inexperience. Recruited from the ranches and farms of the Great Plains, these men, and now women, have not been properly trained for a task of this magnitude. What normally takes years to learn, they must master in just months. While in flight, as is the case with Lockheed's Constellation, overheating is becoming the norm. During one test flight, a B-29 crashes, killing the entire crew, including Eddie Allen, Boeing's chief test pilot. Despite these deaths and setbacks, the project must continue. For America's top generals, the B-29 is becoming a race against the clock. With air bases being built in China, the expected arrival of the Superfortresses is scheduled for April of 1944.
I understand, because of an agreement between Roosevelt and Chiang Kai-shek, that these airplanes were going to be in China a year before they were. So the rush would get them out of the country.
The crew at Boeing, however, is nowhere near completion. Despite this harsh reality, one man, General Hap Arnold, does not throw in the towel. Writing to fellow General Curtis LeMay, he proclaims, "The B-29 project is important to me because I am convinced that it is vital to the future of the Army Air Forces. More concerning are the project's economic costs. By the end of development, testing, and production, the government is estimated to have spent over $3 billion on the Superfortress, a third more than what is spent on developing the atomic bomb." For these generals, it is not only militarily vital that the B-29 succeed. Financially, if the model fails, billions will be lost.
Well, when I got to Wichita, I found out they weren't flying them because the Boeing company had taken this position that the airplane was no good and they weren't going to make them. I understand, second-hand or third, that General Arnold told Boeing officials, "You're going to build that airplane or give us back $50 million we've already advanced for its being." They thought real quick. They said, "Well, we'll build the airplane, but we won't take any responsibility for it." Arnold is reported to have said, "You don't have to take it. The Army Air Corps will take that responsibility."
These ongoing problems become crystal clear in March of 1944. Hap Arnold, on an inspection mission, asks how many are ready for shipment to India. Due to the complications in its design, he is shocked when Boeing's answer is 0. It is for this reason there lies an insurance policy, a backup, a contingency plan in case Boeing fails. And for this possible savior, the American government goes to the other 3 giants of aviation, companies that designed their own version of the Superfortress. The B-30, 31, and 32 can hopefully come to the rescue if all else fails. At least, that is what the government hopes. Lockheed, with their B-30, represents only a token effort. Many are unsure if they can carry through on a project of this magnitude. The plan to make their Superfortress a gigantic bomber version of the Constellation goes nowhere. Their main priority is given to the Connie, which makes it up into the air nearly a year and a half before the B-29 does. The situation is identical at Douglas. Their B-31 design never sees the light of day. Of its 3 competitors, only one gets a plane up in the sky. Consolidated, makers of the B-24 Liberator. They, like Boeing, are commissioned to evolve their design with the B-32, known as the Dominator. Weighing 50 tons, possessing a speed of over 300 miles per hour, and containing 4 2,200 horsepower engines, the aircraft appears to be a carbon copy of the Superfortress.
The B-32 was an outgrowth of the B-24, like the B-29 was an outgrowth of the B-17.
And just like the B-29, the Dominator suffers from the same technical problems. The program is almost canceled in December of 1944 due to development being severely behind schedule. By the end of the war, only a handful of B-32s fly over the Pacific, conducting mainly reconnaissance missions.
The B-32, I had one there at Bomber Test. I flew it. It had no distinctive advantage over the B-29. Matter of fact, I had to order my test pilots to fly it. They didn't much care about flying it.
The key advantage for Boeing is its will and determination. With countless man and woman hours put into this project, combined with billions of dollars in funding, they are determined to complete it no matter what the cost. Being so far along with its development, they must see it through.
The aircraft plants in Wichita adopted suggestion systems where workers could offer suggestions for how to improve efficiency and productivity and actually get cash awards if their ideas were selected by management and then implemented. Many of the amenities that employers offered to workers, like cafeterias, in some cases child care centers, and so forth, were specifically designed to improve productivity and decrease absenteeism rates.
War production is the foundation of our war effort. And by the same token, what you do from day to day affects your country's success in this war. Never forget, you are working for him, for the youth of America, for the boy next door. On the last day of the last war, thousands of such boys were killed. If the war had ended 24 hours earlier, they would have returned. What you do tomorrow, today, in the next hour, can help to bring the last day of this war closer and to save lives that would otherwise be lost. We are all in this together. You and I, your own boy, and the boy next door. Our job is not finished. Let's finish the job together.
With a gun to their heads, the people of Kansas come together and begin rolling Superfortress after Superfortress off the assembly line.
In the essence of wartime conditions, you overcame absolutely any obstacles. It may have taken only 1/10 the time that it would take to solve a technical problem in peacetime. But under wartime conditions, you know, if you can't solve it with 10 engineers, get 100, and that's what the contractor did.
When Arnold, in a fit of rage, demands that 175 B-29s be on time for delivery, this almost impossible task is miraculously accomplished by the people at Boeing, Wichita. Working around the clock for 4 straight weeks, 600 workers meet this goal. compared to a grand total of just 4 in August of 1943. By February of 1945, Boeing Wichita produces 100 B-29s per month. With 20,000 man-hours, these workers are able to produce 4.2 Superfortresses a day, a shining example of both their patriotism and dedication. Until the end of the war, production is right on target. On June 5th, 1944, from an Indian airbase, the first B-29s take to the sky. It has been a strenuous journey, as the aircraft has traveled more than half the world to reach its target. 10 days later, under the 20th Bomber Command, headed by Hap Arnold, 47 Superfortresses depart from Chengdu, China, and begin bombing Japan mercilessly. For the next year, the B-29 becomes the primary tool of destruction in the Pacific. With the Japanese already in a weakened state, they simply cannot compete with this advanced super bomber. Things only get worse as the Americans capture the Mariana Islands. With a shorter range to Tokyo, these strategic outposts do nothing but accelerate B-29 activity over the land of the rising sun. Day after day, Japan is bombed into submission. Led by General Curtis LeMay, his strategy of bomb them and burn them is proving effective. Cities the size of New York, Cleveland, and Pittsburgh are being decimated. LeMay even remarks that by mid-1945, they are going to run out of targets to bomb. That dilemma is solved on August 6, 1945. A B-29, the Enola Gay, flies over Hiroshima, Japan, carrying an atomic bomb on board. The order to go nuclear is given by President Harry Truman. The effect of this new weapon forever changes the way wars can now be fought. The results are devastating. An estimated 80,000 people are killed from the first atomic bomb.
I had seen the city perfectly visible as a place where a lot of humans were moving about. You could see it. You see movement. But when I flew back by it and I was out the co-pilot's window, I look at it, all I saw was something that reminded me of a boiling pot of tar.
3 days later, another superfortress, Boxcar, drops a second atomic bomb on the city of Nagasaki, killing tens of thousands more. These two attacks, in addition to the Soviet Union's declaration of war against Japan, finally causes this once proud nation to surrender unconditionally.
Aboard the USS Missouri in Tokyo Bay, on Sunday, September the 2nd, 1945, the most horrible war in history came to its complete and formal end. Foreign Minister Shigemitsu signed for Japan. Douglas MacArthur, Supreme Commander.
The B-29, with its years of development and construction, proves its worth to the American military. For it is truly the bomber that made the difference.
It's my personal opinion, and I'm sure I'll find detractors, that the B-29 won the war, World War II, in the Pacific.
Oh, I think without a doubt, when you consider particularly the Pacific War, it was the key point in winning it.
And so the people of Wichita, the people of Marietta, the people of Omaha, and the dozens of other towns and cities that contributed to its production go back to their regular lives. Boeing, with no more orders from the government, lays off 70,000 workers at the end of the war. The service they have done for their country, however, does not go unnoticed.
I think historians would argue that war production in the United States was pivotal, if not decisive, in the war effort overall. The United States, over the course of the war, spent more than $50 billion on Lend-Lease aid to the Allies. By 1944, U.S. factories were producing a ship a day and a plane every 5 minutes. But that's a phenomenal amount of production.
In the B-29's history, The men and women in these plants are just as important as Hap Arnold, Curtis LeMay, and those piloting the aircraft.
It's a joint effort of everyone. The maintenance, the supply, everyone contributed to it.
For a 3-year period, of the over 3,000 Superfortresses built, 1,600 of them come out of Wichita alone. On August 29th, in a statement to Boeing employees, General Arnold proclaims, "Thanks to what you did, our combat crews had been trained and B-29s were ready and waiting to occupy Iwo Jima, Saipan, and Okinawa as each base was prepared to receive them. You were given a job to do, and the way you finished that job met our greatest expectations. For myself, and on behalf of the Army Air Forces, I say to you, well done, and thanks from the bottom of my heart." The Superfortress should be remembered as the greatest roll of the dice in American aviation history. In an era where aircraft manufacturers had little to gain with costly military projects, it is amazing that it was able to get into the skies as quickly and efficiently as it did. The race for the Superfortress is also truly an American story. Its industrial capacity and strength, a supply line uninterrupted from bombings and destruction, and a diligent and patriotic workforce is what made the B-29 possible.
This is it. This is the B-29, the plane you've been waiting for. And it was worth waiting for. It's the biggest, fastest, mightiest heavy bomber in the world. It can travel farther and higher than anything else on wings. It has a pressurized cabin, permitting high-altitude flight without oxygen masks. It has 5 remotely controlled, electrically driven turrets, each carrying twin 50s, with a 20-millimeter cannon added to the turret in the tail. Yes, the B-29 is everything you've been promised. And the pilot who flies one has an enviable job. Important, glamorous, and tough. Here's a B-29 pilot. He's measuring the distance between pin centers on the left landing gear. This part of the job isn't so glamorous, but it's the pilot's responsibility to make sure that everything on this biggest bomber in the world works properly. If you were a B-29 pilot, here's exactly what you'd have to do before an operational flight. Check the nose wheel. See that the tires are inflated to 45 to 50 pounds per square inch. While measuring the pressure, look over the tires for general condition also. Watch out especially for cuts or signs of serious wear. One of the ground crew will replace the dust covers, but you're still responsible for his work. After you've measured the pressure in both tires, give the gear a visual check. The strut should be clean, with a clearance between pin centers of 10 inches. And the shimmy damper must be full. That's important. Make sure the rod is almost up to the notch in the gauge on the shimmy damper reservoir. Now you can look over the engine cowlings on your way to the other main landing wheel. This gets the same inspection you've already given its mate. The co-pilot ducks into the wheel well to inspect the equipment there, while you work on the wheels. Measure tire pressures again. On these tires, the pressure should be between 75 and 85 pounds per square inch. Inside the wheel well, the co-pilot examines the wires, connections, and switches. He makes sure all the cannon plugs are on tight, paying particular attention to the plugs on this motor, which opens and closes the nacelle doors, and also to the plugs of the normal and emergency landing gear motors. Then he turns around to examine his side of the strut. He looks it over and inspects the brake lines, making sure that the hose is not chafing and no fluid is leaking. Meanwhile, you're checking the clearance between pin centers again. 13 1/4 inches. Right. Now, are the wheel chocks in place? One behind the inboard tire and one in front of the outboard tire, just as it should be. Next, check the cowlings, inspection doors, and inspection plates. You've already examined some of them, but you must be sure all of them are okay. The other members of the crew help you out with these inspections. Here, for example, a gunner tests the fastening of the top cowling. But you'll have to check the security of the other coverings, and there are a lot of them all over this ship. While you're walking along, you can examine the wing seams. Fluid leaking from them means trouble. Now to check the ailerons and trim tabs. All control surfaces and all trim tabs must be inspected. Test the tabs for excessive hinge play by shaking them, and see that the gas tank caps are tightened. If there were extra fuel tanks in the bomb bays, their connections would have to be examined. But now the pilot and the co-pilot continue their tour around the plane. They have a lot to check. Hatches, windows, control surfaces, trim tabs, inspection plates, and doors. But the pilot and co-pilot aren't the only crew members with inspections to make. The gunners, for example, besides helping the pilot check the airplane, must also be sure the guns and gun cameras will work properly. They must inspect all 5 turrets in the same way they're now examining this lower rear turret. After they have the dome and gun cover removed, they see that the ammunition moves freely in the chutes and is correctly loaded. The guns just don't fire with the cartridges in backwards. They also check the safety wiring on the gun mounting bolts, up in there. Then the gun charging switches are put on reset. That conserves the CO2 pressure, which automatically charges the guns. Finally, the gun camera is inspected. Enough film, speed set at 16 frames per second, lens adjusted to the brightness of the day, and the interval control put at the desired number of seconds and turned on. And this turret is all right. The dome and gun cover can be replaced. The tail turret is checked by the tail gunner, but again the pilot is responsible. If the guns fail, he gets the blame. So he watches the tail gunner as the Shatterall feed mechanism is inspected. Now the other gunners only have to lock the latches. Elevation latch locked. Azimuth latch locked. The doors are shut and fastened, and the gunners can go to another turret. And there's still more work to be done. Each engine must be pulled through 15 blades, with only 2 men per blade. The engineer takes care of that. He sits at his position, making sure that all switches are off, while the 4 engines are pulled through. And now the co-pilot puts on his clothing and collects his equipment before joining the rest of the crew for inspection. Notice that the crew members wear fatigues while making their inspections, and change into flight clothing only when they are ready to enter the plane. The examination of the exterior of the airplane is completed, so the crew can fall in for the check of their personal equipment. That's the last item of the before entering the airplane part of the procedure, and it's strictly the pilot's job. Your job. You are responsible for the men as well as the plane. If they fail, you're at fault. Each crew member must have his electrically heated flying clothing, parachute, oxygen mask, knife, a quart of water, and Mae West. Steel helmets and flak vests are already inside the ship at the positions. Apparently these men are completely equipped. But don't think they only have to climb into the ship and fly away. There's a lot yet to be done. Let's go along with the pilot again and see what he has to do to take a B-29 into the air. He climbs in through the hatch in the nose wheel well. That entrance is also used by the co-pilot, engineer, navigator, radio operator, and bombardier. There's work for every man before the engines are started, during engine starting and warm-up, before takeoff, after takeoff, and then a whole list of additional things to do before landing again. As soon as the radio operator gets in, he climbs back to close the pressure door between the forward compartment and the forward bomb bay. The bombardier is the last one in, so he closes the hatch. The gunners close the pressure doors in their compartment. They also open the cabin pressure valves, which will now automatically maintain the cabin pressure at the desired level. 3 compartments in the plane, the pilot's compartment, the gun control compartment, and the tail gunner's compartment, are sealed off from the rest of the fuselage and supplied with this compressed air. The cabin pressurizer keeps 8,000 feet altitude inside the plane until the outside is at 30,000 feet. If the plane gets higher than 30,000 feet, the pressure inside drops off gradually, but it is always 13.4 inches of mercury more than the outside pressure. But let's get back to flight procedure. The gunners take care of the other pressure door in their compartment. But what about the pilot? That's you. You already have your chute fastened, your Mae West on, and the seat adjusted. So you put your throat microphone and earphones on. If you put the mic on first, you won't get so badly tangled in the wires. Don't forget to plug in your disconnector cord. Now to start work. Ask the engineer for Forms 1, 1A, and 01-1-40, and look them over. Be sure that everything on Forms 1 and 1A has been checked. Pay particular attention to the list of defective equipment. If anything vital is out of order, it must be fixed before taking off. The weight and balance computation is in Form 01-1-40. That's important. Make sure it's correct. When you've examined all the forms and signed them, you can give them back to the engineer and tell him to start the putt-putt. You have to turn on the emergency ignition switch. The tail gunner looks after the putt-putt, starting and stopping it on orders from the engineer. But now, you set the jackbox selector switch to command and turn on the proper command receiver and the command transmitter. This puts you in communication with the control tower. Now examine your own equipment. Look over your oxygen mask and make sure your portable oxygen bottle is fully charged. Then try out the cockpit lights. To test the ultraviolet lamps, turn on the switches and twist the shutter. You should then be able to see the light. By turning the shutter back, you can control the amount of ultraviolet light emitted. Next, try out the alarm bell. The gun commander will tell you if it's working. Then depress the brake pedals and pull out the parking brake knob to set the brakes. Look over to the control stand and make sure that the emergency releases and switches are correctly set. Power transfer switch, emergency landing gear release, emergency bomb release, emergency cabin air pressure release, and pilot's over control. Now unlock the control surfaces and throttles by moving the locking lever on the aisle stand full forward. Then release the throttle brake and test all 4 throttles through their entire range. Take it easy, move them slowly and gently. All controls on the B-29 should be handled in this careful manner in order to prevent damage to the mechanism. There's no need to push hard. And the co-pilot doesn't just sit and read the checklist. He must test the action of the control surfaces, moving each surface, elevators, ailerons, and rudder through the complete range. The gun commander looks from his blister, observing the response of the surfaces, and reports to the co-pilot. A similar test is made on the trim tabs. The co-pilot turns the 3 control wheels as far as they will go in each direction. That big wheel on the side of his control stand operates the elevator tabs. The aileron and rudder wheels are on top of the control stand behind the throttles. The way the trim tabs follow the setting of the control wheels is also observed by the gun commander, who tells the co-pilot over the interphone how the tabs move. The co-pilot turns the tabs back to neutral after testing them. And now to try out the wing flaps. But first he calls the side gunners on the interphone to make sure none of the service crew will be in the way of the descending flaps. When the gunners report that it's safe to go ahead, the co-pilot presses the flap switch to the down position and holds it there until the flaps have been lowered 15 degrees. 15 degrees is enough to tell if they're working all right. The co-pilot can't see the flaps, of course, so he watches the wing flap position indicator. But the gunners can check visually. They tell the co-pilot if the flaps come down all right. So now he can bring them back up. The gunners, again, will tell him when they're up. Don't start thinking the gunners have nothing to do but watch control surfaces and flaps. They have their own checklists to follow. The right side gunner, for example, is looking over his supply of spare lamps and fuses. Yep, that's okay. But now you, the pilot, are almost ready to start the engines. See that the automatic pilot master switch is off. Check over the 4 sets of control surface adjustment knobs, making sure all their pointers are up. Then set the manifold pressure selector to the 0 position. And depress all 4 propeller RPM switches to the increase position and hold them there until the lights on the co-pilot's instrument panel flash. Now you're all ready to start the engines, and the rest of the crew should be too. They check in with the co-pilot, reporting in this sequence. Bombardier, who sits directly ahead of the pilot and co-pilot. Navigator, who is some distance behind the pilot, facing forward. Flight engineer, who is directly behind the co-pilot, facing aft. radio operator, who sits across from the navigator and faces the right wall, gun commander, who is in the top of the fuselage amidships and can face in any direction, left gunner, who faces aft, right gunner, who also faces aft, and the tail gunner, who stays close to the putt-putt during takeoff and landing. His combat position, of course, is in the tail. Everybody set now. Warn the service crew outside you're going to start the engines, and tell the engineer to start number 1. And number 1 engine spins twice. And now he turns the fuel boost pump on, closes all the throttles except number 1, sets the fire extinguisher to number 1 engine, presses the starter switch to energize, and then flips it to start. And finally turns the magneto switch to both. You have to push the throttle to 1200 RPM and signal for number 2. The same procedure is repeated until all 4 engines are running. Now that the engines are going, vacuum pressure is available to operate your gyro flight instruments. So the gyro compass and the flight indicator can be uncaged and set. The co-pilot will be doing the same with his gyro instruments. Next, see if the other vacuum pump is working all right. Have the engineer switch to the pump on the number 2 engine. The vacuum may drop some, but it should go back to about 4 inches. Now you can call the control tower on the command radio. It's already on. This is about the right time to get your taxiing instructions, since you'll soon be ready to move out to the runway. At the same time, ask for the field barometric pressure so you can adjust the altimeter. It must be set carefully to the correct pressure, in this case, 29.84 inches. Obviously, an accurate altimeter is a vital necessity, especially if you may have to fly on instruments. Next, you want the bombardier. You know he sits back with the navigator and the radio operator until the ship is in the air. But right now he has to come forward to make the final checks on the bomb site. He's already completed the regular pre-flight inspection of his equipment. All he must do now is see that the bomb site is entirely ready for takeoff. The directional clutch should be disengaged and the secondary clutch engaged by turning it clockwise. Then the drum wheel must be turned counterclockwise as far as it will go. That does it. He's all set to take off. And now you're ready to close the bomb bay doors. Ask the ground crew outside if there are any obstructions underneath the plane. Everything's clear, so you can order the bombardier to close the bomb bay doors. He throws the door switch while you look back through the pressure door to watch them shut. The rear bomb bay door is looked after by one of the gunners, who will tell you when it's closed. When both doors are shut, the bombardier can go back to his takeoff position in the rear of the compartment. And you're almost ready to taxi, but you better make one last check of the turret warning lights. Uh-oh, that lower rear turret light is on. Call one of the side gunners and have him take care of it. Perhaps the turret wasn't stowed. Forget about it, gunner? Well, it's easy to fix. Get control of the turret, press the action switch, and stow it. That does it. There, that turret warning light is off now. And everybody's set. Switch your jack box back to command and signal the ground crew outside to remove the wheel chocks and get a safe distance away from the airplane. The co-pilot warns the crew to stand by to taxi. And you can release the brakes and move the ship out to the runway. While taxiing, or whenever the plane is moving, all crew members watch from the windows and keep the pilot informed of obstructions. The gunners can provide the most help since the blisters give them a wide view. This is a big airplane. It's mighty easy to hit a fuel truck or another ship and clip off part of the wing or stabilizer, and that doesn't help the flying characteristics a bit. Notice the flaps are kept in the up position. If you taxi with them down, the undersurfaces are likely to be damaged by pebbles blown back by the propellers. After you've stopped at the edge of the runway, put in your call to the control tower for permission to taxi on the runway. When the tower has given the clearance, move on the runway. Steer with the outboard engines, not the brakes. Excessive use of the brakes on a plane as heavy as this one will wear them out quickly, As the ship is turned around at the far end of the runway, notice again how the engines are used for steering. You can see the right propellers moving faster than the left. When you're at right angles to the runway, stop for the engine run-up. Tell the flight engineer to get ready to make his magneto check while you run the engines up, one at a time. First, press the propeller RPM switches to the increased position, holding them there until all the propellers are at maximum RPM. Next, turn the manifold pressure selector to position 8. With the knob in this position, the superchargers automatically provide military power. Now, advance the number 1 throttle, but slowly and gently, to 2000 RPM. Hold this speed until the engineer tells you the magneto check is finished. Then press the propeller RPM switch to the decreased position until the tachometer drops about 200 RPM. Now flip the switch to the increased position and hold it there until the light on the co-pilot's instrument panel flashes, and then push the throttle to full open. The tachometer should show about 2600 RPM for the number 1 engine, while manifold pressure should be around 47 inches. To see if the turbo is working properly, turn the manifold pressure selector towards 0. That should make the manifold pressure drop. The turbo's okay. Bring the throttle back to idling, around 550 to 600 RPM, and increase speed to 1200 to avoid fouling the spark plugs. Next, start on the number 2 engine. This same procedure is repeated for each engine. Now you're about set to take off. After you're cleared for takeoff, turn the plane the rest of the way around so that it points down the runway. And stop again while the co-pilot lowers the wing flaps about 25 degrees. He can tell when they're right by looking at the wing flap position indicator. And the gunners can check on the accuracy of the indicator by watching the flaps from their blisters. They report on the approximate flap position over the interphone. When the co-pilot tells you the flaps are okay, fasten your safety belt and set the manifold pressure selector to position 8. Next, set the propeller RPM switches to increase RPM and wait for the lights on the co-pilot instrument panel to flash. Then warn the engineer to be ready for takeoff. Stand by for takeoff. Now you push on the brakes, hard, and open the throttle slowly until the manifold pressure gauge reads about 40 inches. Then release the brakes. As you gather speed, slowly advance the throttles to full power and set the throttle brake. Manifold pressure should go up to 47 or 47.5 inches. RPM should go up to 2600. Continue accelerating down the runway until the indicated airspeed gets up to 95 miles per hour. Then slowly pull the control column back, putting the ship in a flying attitude. The plane takes off without further action on your part when it gets flying speed. The exact speed at which it will leave the ground depends on the weight. When the ship is airborne, apply the brakes to stop the wheels, and then have the co-pilot retract the landing gear. He has to hold the landing gear retracting switch in the up position because the switch is spring-loaded. The co-pilot makes sure the nose gear is up by looking through the inspection door on the floor of the cockpit, just ahead of the aisle stand. The wheel is there, all right. At 160 miles per hour and 500 feet altitude, the co-pilot retracts the flaps, snapping the switch on and off until the indicator shows that the flaps are all the way up. The side gunners should be watching from their blisters as the plane takes off. They tell the co-pilot when the flaps and landing gear are up. Now you ought to change from takeoff power setting to climbing. Adjust the manifold pressure selector until the manifold pressure drops to 43 inches. And decrease propeller RPM to bring the tachometers to 2400. You can order the engineer to have the putt-putt turned off now, and tell the bombardier to come forward and take his combat position in the nose of the ship. If this is an operational flight and enemy opposition is expected, have the men put on their flak vests. These vests are made of small overlapping links of tough steel sewn inside canvas. Quilting on the inside of the canvas provides further protection and also cushions the shock of impact. Above 10,000 feet, oxygen masks must be worn by one man in each compartment. When you reach the desired altitude, level off and tell the engineer to set up cruising conditions. First, you move the throttles back to about 65% of full power. Individual manipulation of the throttles may be necessary to keep each engine at the same manifold pressure. Now you adjust the propellers and manifold pressure, so turn the controls over to the co-pilot. Start with the props. Press the propeller RPM switches to decrease and bring all 4 propellers to 2,000 RPM. Then turn the manifold pressure selector down until the manifold pressure drops to 30 inches. The needles should stay together in this case. There you are, 30 inches. Considerable juggling of throttles, propellers, and supercharger may be necessary before you get it just right, but that's how you get a B-29 into the air. It's a big, heavy, and powerful airplane. Bigger, heavier, and more powerful than anything you've ever flown. For that reason, it must be handled gently and precisely. You must carefully follow the prescribed procedures. Even a super bomber is no good to the Army if it's in little busted up pieces. But don't get jittery. The 29 is a sweet ship to handle. When it stalls, the nose drops so that the plane automatically recovers. There's no tendency to spin. Stalling speed varies quite a bit naturally depending on weight and other conditions, but generally it's between 84 and 135 miles per hour. When turning or executing any maneuver, take it easy. This is a big plane, remember, not a fighter. Yet fairly steep turns can be made safely. This 30-degree bank can also be done with full flaps. That's about the limit. And when evasive action is necessary, you have plenty of tricks to pull. Just watch this B-29. And the B-29 does more than just fly well. It packs a terrific wallop. A wallop enemy fighters will quickly learn to fear. That turret you see moving is only one of the 5 on the ship, which mounts a total of 10 machine guns and 1 cannon. 4 of the turrets, 2 on top and 2 beneath the fuselage, can turn through 360 degrees in azimuth, 90 degrees in elevation. The tail turret is more restricted in movement, but it has a 20-millimeter cannon in addition to the twin 50s the others carry. But the big thing about the 29's armament is the fact that the gunners don't touch the guns. The guns are controlled remotely from special sights, and any gunner can fire almost any turret. For example, one side gunner might have control of 2 turrets, firing 4 caliber 50s at his target. That's only the beginning of the story about guns, so let's get back to what a pilot has to do. Now you're ready to land. Since you've descended below 10,000 feet, remove your oxygen mask. Tell the co-pilot to take over control of the ship so that you can get out of your flak vest. The vest is easy to take off. Just pull on the cord and it drops away. This speed of removal becomes important if you ever have to bail out, since the vest is worn over the parachute and, well, you figure it out. If you've been riding with the automatic pilot, turn it off. You can't use it for landing, of course, or when taking off, flying turbulent weather, or setting trim tabs. The co-pilot should now warn the crew to prepare for landing and tell the bombardier to climb out of his seat in the nose and get in back with the engineer. Then the co-pilot has the engineer start the putt-putt. You check the turret warning lights. All the lights are off. Then call the control tower and get landing instructions. At the same time, ask for the field barometric pressure and set the altimeter to correspond. Now the co-pilot hits the brakes to test the hydraulic pressure. Both normal and emergency systems should have 800 to 1,000 pounds. To find out about the emergency pressure, you have to ask the engineer. At the same time, you can see if he's ready to land and get his log. He has calculated the new weight and center of gravity, since you've used up a lot of gasoline by now. You should look the log over, but the co-pilot will check it carefully, examining the center of gravity and weight computations. The table on the instrument panel gives the stalling speed for the computed weight. The co-pilot tells you the stalling speed and also reports that everybody in the crew is ready to land. Next, you adjust the propeller RPM switches. Push them to increase until you get the tachometers to show 2100 RPM. Now adjust the manifold pressure selector to give you plenty of reserve power. Turn it all the way up to position 8, the setting for full military power. When the plane is slowed down to 180 miles per hour or less, order the co-pilot to lower the landing gear. When the switch is set to the down position, the wheels descend all the way, lock, and the gear motors automatically stop. When the left and right gear are down, the side gunners, who should now be watching the wheels and flaps, will report to the co-pilot. He himself can make sure the nose wheel has been lowered all the way by looking through the window in the floor of the cockpit. Next, the flaps should come down. If you've been in combat, the co-pilot should lower them first only 5 degrees. If they were damaged, lowering them all the way might rip them off the wing. The gunners can look them over and report on their condition. The flaps are all right, so the co-pilot can lower them 25 degrees. Notice that he snaps the switch on and off. That way, the flaps descend gradually, and a sudden change in the lift characteristics of the airplane is avoided. The gunners will report when the flaps appear to be down 25 degrees, and the co-pilot can check by looking at his wing flap position indicator. When he has the flaps where he wants them, he'll tell you. Then you'll probably have to reset the trim tabs because of the change in the flap position. Next, adjust the throttle brake to a comfortable tension. And don't forget to turn off the detonator power switch. Now make a standard approach, keeping the speed about 30 miles per hour above stalling. And, on the final approach, order the co-pilot to lower the flaps all the way. When you touch the ground, the plane should be slightly tail low and going between 95 and 100 miles per hour. Notice how the main wheels bear most of the shock of landing. Then the ship slowly settles forward. Don't apply brakes immediately. Let the plane lose some of its speed rolling. Then turn the manifold pressure selector all the way back to 0. You won't need the turbos anymore. And set the propellers at increase RPM. Raise the flaps now while you're taxiing and have plenty of power. You're down now. You've followed your checklist step by step. But there are other checklists, the engineers, for example. So suppose we go back over that landing procedure and see how the engineer's checklist fits in with yours. 5 minutes before landing, the engineer tells the tail gunner to start the putt-putt. The ship enters the traffic pattern at a 45-degree angle to the downwind leg. Altitude is 2760, speed is 180. Here the co-pilot lowers the wheels. The mixture controls are set to auto-rich, and the cowl flaps open 15 degrees. At the end of the downwind leg, the speed should be about 140 or 150, and at least 3 generators must be on. The co-pilot lowers the flaps 15 degrees. After the pilot makes the procedure turn, the altitude should be 2260 feet. The co-pilot lowers the flaps to 25 degrees. The pilot sets the manifold pressure selector to position 8 and adjusts the propellers to 2100 RPM. Just before the final turn, the engineer checks the magnetos and turns the boost pumps on. Around the turn, on the final approach, speed should be at least 140, altitude 800 feet. Also, 6 generators should be on. Finally, the co-pilot lowers the flaps all the way and calls out airspeed and hydraulic pressure as the ship descends to the runway. After the airplane's on the ground, turbos come off and propellers are set to full increase RPM. The engineer switches the boost pumps off and opens the cowl flaps all the way. All right, we're back where we were before. Tell the bombardier to come forward and open the bomb bay doors. The doors should always be kept open when the ship is standing still to prevent the accumulation of gas fumes. Next, turn off all the switches. Then you can get rid of some of your equipment that remains inside the ship and climb out for the after-flight inspection. Yes, you start with an inspection and finish with an inspection. If there was anything wrong, now is the time to find out about it. And now is the time to correct it. Yes, this is the airplane that you've been promised. Now it's up to you to weld this airplane and its crew into a single, irresistible instrument of destruction. That can be your promise to us.
Along the unyielding road of time, in the span between past and future, certain events have seized human imagination and shaped his worldview. One such event occurred not long ago, a colossal war waged with machines that scarred the land, seas, and skies. This is the tale of one such machine. The B-29's roots trace back to Boeing's Model 316 project, a direct successor to the XB-15 of 1934. Additional designs emerged over the ensuing years, with the 345 design formally presented to the U.S. Army on May 11, 1940. The Army was sufficiently impressed to grant Boeing funds for further studies and wind tunnel tests on June 17th. 3 years and multiple designs later, the first B-29s began rolling off the production lines at Boeing's Wichita plant in Kansas. By September 1943, 2 other major companies were producing B-29s alongside Boeing. Martin operated from its Omaha plant in Nebraska, while Bell built them in Marietta, Georgia. Together, these 3 facilities delivered a total of 2,513 B-29s. Measuring 99 feet in length and spanning 141 feet 3 inches, the B-29 was anything but small. In fact, it was the largest bomber in the world, with a wing area of 1,736 square feet. Coupled with a height of 27 feet 9 inches, the aptly named Superfortress stood as a towering giant, weighing 74,500 pounds empty and 135,000 pounds fully loaded. Building such a colossal aircraft required vast amounts of space and a meticulously organized construction system. On the factory floor, hundreds of specially trained workers toiled to construct an aircraft of immense proportions. This diverse workforce included people from all walks of life. Individuals worked side by side while the older teamed up with the young and younger. No one was too old to contribute or too young to matter. Every person brought a valuable skill, regardless of their shape or size. Once assembled, these frame sections came together to form the world's heaviest bomber, and getting such a machine airborne required immense power. That power came from 4 Wright R-3350 duplex Cyclone 18-cylinder radial engines, each equipped with GE turbo superchargers, delivering 2,200 horsepower at takeoff and 2,300 horsepower at 25,000 feet. The frame supporting these engines had to be expertly constructed. A single missed rivet, combined with vibrations from the engines, could cause the entire plane to break apart mid-air. Once fully assembled, the B-29 was nearly ready to depart the plant. Only minimal finishing touches remained, as it was built as a machine of war, requiring little in terms of paintwork or aesthetic details. On a production line like this, completed planes didn't remain idle for long. The moment the final rivet was secured, the B-29 was towed out of the factory and handed over to the men who would ultimately gamble their lives on its reliability. The pilots destined to fly these formidable warbirds left nothing to chance. The B-29 underwent a rigorous series of tests before its first flight. Every inch of its exterior assembly had to be meticulously inspected by the pilot and crew, who ensured nothing was overlooked. Tire pressure had to be precise, maintained between 75 and 85 pounds per square inch. Detailed measurements were taken to confirm that no moving parts had shifted beyond acceptable limits. At a cost of $639,000 per plane, caution was essential, requiring a thorough inspection of every component, no matter how minor. As the pilot walked around the aircraft, he carefully examined the bodywork for any defects. After verifying the tire pressures on the next wheel, the pilot carefully inspects each motor cable, checking for any signs of damage or breaks. These motors control the landing gear, and a failure here could prove catastrophic. Once the wiring is inspected, the pilot examines the brake lines, ensuring the hoses are intact and free of leaks. Next, the wheel chocks are checked. One positioned behind the inboard tire, and another in front of the outboard tire. The B-29 carried an immense 9,438 gallons of fuel distributed across 26 wing tanks and 4 bomb bay tanks. A leak in any of these tanks could trigger a devastating fireball. The aircraft also boasted a formidable array of onboard weapons. Within the versatile remote-controlled turrets positioned around the aircraft lay 50-caliber machine guns, each requiring meticulous inspection. With its outer shell removed, the belly turret exposed the weapon housed inside. These turrets enabled the guns to be angled in multiple directions, operated remotely from within the aircraft. Routine maintenance of both the gun and turret was vital to ensure the safety and effectiveness of the operator. For obvious reasons, extra care was given to inspecting these critical components of the aircraft. The B-29 was not built as a fighter, and while it could reach speeds of up to 357 miles per hour, it couldn't outpace faster enemy fighters. Fortunately, its designers anticipated this and equipped the plane with 8 separate remote-controlled gun turrets. An enemy wouldn't take down a B-29 without a fight. The designers also added another innovative feature: cameras installed in some gun turrets. These captured footage of the B-29's guns in action, providing tactical insights at the time and, 50 years later, offering historians a valuable glimpse into the war. The B-29 truly had a sting in its tail. Two 50-caliber machine guns and a 20mm cannon for good measure. While these guns shared a similar range of motion to those in the turrets, the cannon's shell trajectory differed from that of the machine guns. This disparity made aiming challenging, leading to the cannon's eventual removal from the tail section. Before boarding the aircraft, one final task remained: the crew. Each crew member had to be checked in and thoroughly briefed by the pilot. A few choice words of encouragement were usually enough to lift their spirits and prepare them for the task ahead. This would be their last chance to feel the ground beneath their feet for several hours. Once everyone was present and accounted for, it was time to board. Upon entering the plane, the crew immediately headed to their stations and made themselves comfortable. Anything they brought with them had to be securely stowed, and the exterior hatches sealed tight. This was especially crucial for the B-29, as it featured pressurized compartments that maintained consistent air pressure throughout the mission. The pilot couldn't do much until he established contact with the rest of the crew. Starting with his throat microphone, he would put on his headset and plug it in. By flicking a few switches and turning the transceiver to the right frequency, he would establish communication with the control tower. Next, the pilot would conduct a brief check of the gas mask and inspect the portable oxygen cylinder. He would then test the cockpit lights and ultraviolet lights, flicking them on and opening the shutter for a visual inspection. Following that, he'd give a quick blast on the alarm bell, and the gun commander would confirm its functionality. Every internal system underwent this thorough check. It was now time to start the engines. Each engine had to be turned through 15 blades before it could be started. Once this procedure was completed, the ground crew would step back, and the pilot could start the engines. After all 4 engines were running, vacuum pressure became available to operate the gyro flight instruments. At this point, the gyro compass and flight indicator were uncaged and set to the correct settings. A few more checks and procedures remained before taxiing out onto the runway. Not long now, and the airmen would be airborne. With wheels up, the co-pilot raised the wing flaps, and a visual check confirmed they were properly set. It was time to see what this bird could do. The bombardier took a quick look, but no bombs would be dropped today. This was just a test flight. Time to head in. Wing flaps down. Now, let's see how well she lands. The wing flaps must be fully extended for the approach. A textbook landing. The back wheels touch first to absorb the impact, followed by the front wheel coming down gently. It doesn't get much smoother than that. This was just a test flight, and these airmen had an easy ride. However, 10,000 miles away, a fierce battle was raging, and soon these men and their brand new B-29 would be called into action. When Japan attacked Pearl Harbor on December 7th, 1941, they made a powerful enemy out of America. The reasons for the attack were unclear, and ironically, Japanese envoys were holding peace talks in Washington at the time. However, that one fatal mistake brought America into the war, and U.S. troops were soon engaged against the Japanese. To bring their B-29s closer to Japan, America needed an airbase large enough to accommodate them. On the Pacific island of Saipan, they found such a place. After landing on Saipan on June 15, 1944, U.S. Marines captured the island's airbase within 3 days. However, the Japanese defenders continued to fight, and the battle didn't end until July 9th. By then, an estimated 30,000 Japanese soldiers and civilians had lost their lives. Some, including 2 commanders, chose to commit suicide as defeat neared. U.S. casualties numbered over 16,000, with 3,000 dead. The Battle of Saipan secured America its airbase and wouldn't be long before the first B-29 would arrive. But before that, bulldozers would be sent in to prepare the runway. Other airfields were also being readied in eastern China. 500,000 Chinese farmers and laborers transformed acres of paddy fields into runways specifically designed for the B-29. These dedicated workers used nothing but their bare hands and the simplest of tools. No pair of hands went to waste in this operation. 3 months later, the skies were filled with B-29s heading east. For the men aboard these massive bombers, there was only a silent farewell to the California sun, and perhaps a prayer for their safe return. But farewells couldn't last long. There was still work to be done, and unless they wanted to run out of fuel over open sea, these men had to stay vigilant about their course heading. For a while, all they had to look at was the endless expanse of open sea. That, and the couple of hundred other B-29s flying alongside them. The view could get monotonous with nothing but sea and sky for miles, and the only comfort was looking out the window at their fellow airmen. Land. The relief on this pilot's face says it all. The long journey from America to Saipan has finally come to an end. While the sight of the base is the best thing these pilots have seen all day, it won't be long before they'll long for the comfort of home. The ground crews have been waiting for the arrival of their comrades for a long time. And for the dust-covered residents of Saipan, the crews of these first planes are the best sight they've seen in months.
The first element of the 21st Bomber Command has arrived. When we've done some more fighting, we'll do some more talking. Thank you.
These pilots and their crews have just landed, but already they're receiving a hero's welcome. Maybe they'll return to America, covered in glory, or perhaps their celebrations won't last long, nor will their rest. At the 21st Bomber Command headquarters, plans for their first mission are already in motion. Today, the target is Tokyo. The weather's too cloudy to strike anywhere else. Major General Curtis LeMay believed he could force Japan's surrender through the sheer weight of relentless attack. To this end, he ordered a rapid pace of operations. 4 wings will strike Tokyo at 10 o'clock. They'll fly in under the weather and bomb at 12 noon. Operations has reviewed the tactical plan for Target 574. General LeMay approves the target and commits all executive details to his staff. By flying 600 plane missions out of Saipan, Guam, and Tinian, LeMay doubled his command's bombing weight in just 2 months. That was his no-nonsense style. With the increased frequency of LeMay's attacks on Japan, it became essential to carefully track the amount of bombs and ammunition being used. The B-29 could carry 20,000 pounds or 4 tons of bombs, and when you multiply that by the number of planes in operation and the number of missions flown, it's clear how much planning was needed to manage the distribution and usage of these weapons. Another key aspect of LeMay's tactics was keeping as many B-29s in operation as possible. This meant a lot of work for the engineers who maintained the B-29's engines. The pilots, who not long ago had arrived, fresh-faced and eager, were now veterans of several missions over Japan. Some had already seen action in Europe, while others were more innocent. It's a testament to their courage and resilience that, in the face of potential early death, these men could so easily throw their heads back and laugh. Men like Colonel Kenneth Gibson from Salt Lake City, who served in both England and the Far East, John Van Trigg from Illinois, Gordon Wong from Idaho, Fred Montgomery, a B-24 gunner, Harry Grant, a B-17 flight chief, decorated for his actions in the battles of Guadalcanal. Men who had flown in forts or liberators across various combat theaters and had graduated to the newest and best. It had been a long time since any of them had seen their homes or loved ones. In the pilot's briefing room, the Tokyo mission is laid out for them. The news comes as a relief to these men, but they are under no false illusions. Many of them have flown missions to targets in Europe, but this is different. The London to Berlin run was 1,000 miles, there and back. A return trip from Saipan to Tokyo covers 3,000 miles over enemy territory. Before the mission, the pilots endure a few moments of unwanted leisure. They are eager to get airborne, but until final clearance is given, there is nothing to do but wait. The lead plane for this mission will be Don Pistote, piloted by Robert Morgan, with bombardier Vince Evans on board. They were the pilot and bombardier who flew 25 missions over Germany in a B-17 called the Memphis Belle. They could have gone home after their service, but they chose to continue serving. At last, the green light is given, and these two heroes can take to the skies once more. During the mission, the crew members are confined within separate pressurized sections of the aircraft. The bombardier sits at the nose of the craft, directly ahead of the pilot on the left and the co-pilot on the right. Behind the pilot is the navigator, facing forward. The flight engineer sits directly behind the co-pilot, facing up. The radio operator is across from the navigator, facing the right wall. The gun commander is positioned at the top of the fuselage, amidst the ship's structure. The left gunner faces aft, as does the right gunner. The tail gunner stays at the rear of the craft, moving to the tail when combat begins. When the B-29 came under attack from enemy fighters, it was the P-51 Mustang that provided protection, acting as a long-range escort and close air support fighter. The B-29's gun commander didn't remain idle. The gun commander had control of all the B-29's guns and was fully capable of dispatching enemy fighters when necessary. From his vantage point at the top of the fuselage, he could see enemy fighters approaching and had the time to choose the most effective turret to control. The other gunners also had control over their respective turrets, coordinating to launch a devastating counterattack. The B-29 was equipped with 10 50 caliber machine guns, each carrying 500 rounds, and a 20mm cannon in the tail with 100 rounds. The total onboard firepower amounted to 7,000 rounds. From the gun blisters, the gunners could aim and fire with deadly precision. Now, the B-29s had reached Tokyo and were rapidly approaching their target. At this point, the bombardier would take control of the plane, using his scope to locate the target and begin the bombing run. Once the cloud cover cleared enough for the bombardier to visually confirm he was above the target, the order was given to open the bomb bay doors. The bombardier took a final moment to ensure his position was accurate, and then, with a quick decision, released the bombs. Bombs away. It took 3 days for the smoke to clear after the attack, and only then could the true extent of the damage to Tokyo be assessed. The sight of Japan's devastated capital served as a grim reminder of the destructive power of war. The B-29 crews, however, were unaware of the full extent of the damage they had caused. All they knew was that they had successfully completed their mission and taken out a key enemy target. They had flown for Uncle Sam, and now they were flying for themselves. The journey back to Saipan was a grueling 1,500-mile flight, and throughout the entire return leg, the victorious B-29s remained in constant danger of attack. Just flying an American bomber over Japanese airspace was enough to provoke enemy fighters. But on this particular return flight, the threat came not from intercepting fighters, but from flak. A lucky pilot might only lose the use of one engine after taking a hit from flak, and as long as the landing gear remained undamaged, he stood a good chance of making a safe landing. Unfortunately, this crew wasn't so fortunate. Their plane came in uncontrollably, its engines severely damaged, and the landing gear was crippled. The man who stood watching this devastating accident might have experienced a mix of emotions, but his lack of visible response suggested that he had seen similar events happen before. Some pilots in dire situations like this found a convenient stretch of water to splash down on. The pilot of the damaged B-29 made a wise decision, choosing to bring his plane in for a controlled landing on water rather than attempting a parachute escape. The pressurized compartments of the B-29 made a quick evacuation nearly impossible. Miraculously, the pilot managed to land the plane with perfect control, and all crew members survived. The aircraft would soon sink and become part of the ocean's ecosystem. For the crew of the second plane, what initially seemed like a routine landing turned into a tragic disaster. While the exact cause of the crash remains unknown, the fire crews responded quickly, aware that the vast amounts of aviation fuel on board could make the fire much more dangerous. Despite their efforts, the blaze was fierce and hard to control, requiring gallons of foam and a team of dedicated rescuers to try to save the crew. Sadly, only one member of the plane's crew was rescued from the burning wreckage, a stark reminder of the risks faced by these airmen in combat. As the B-29s carried out their missions, the efforts to extinguish the aftermath of their attacks, often involving intense fires from aircraft fuel and other incendiaries, became a regular part of the battle. Fire crews, working tirelessly through the night, had to combat blazes that could destroy entire aircraft with a single spark. Despite the terrifying risks, most of the B-29s returned home, having survived their perilous missions and the dangerous elements of warfare. The impact of LeMay's relentless bombing campaign was undeniable. Japanese cities and villages were left in ruins, and the death toll soared as a result of the constant bombardment. However, rather than crippling Japan's resolve, the attacks had the opposite effect, provoking a fierce response. With their backs against the wall, the Japanese forces regrouped, becoming more determined and increasingly dangerous. As LeMay's policy of hit 'em hard continued, Japan's resistance grew, setting the stage for an even fiercer conflict in the skies. On August 6, 1945, Colonel Paul Tibbets and his crew aboard the Enola Gay prepared for a mission that would change the course of history. The aircraft had been specially modified to carry a solitary, unprecedented payload. Tibbets is carrying Little Boy to Japan, and its mission is a closely guarded secret. Inside Little Boy lies a terrifying power, one that is unleashed only when an atom is split. A force equivalent to 20 kilotons of destruction, ready to strike Hiroshima. The atomic bomb. On August 9th, a second bomb, Fat Man, was dropped on Nagasaki from Boxcar, adding its devastation to bring the death toll to 110,000. On August 10th, the Japanese emperor communicated Japan's desire for peace, and on September 2nd, 1945, Japan officially surrendered aboard the USS Missouri, marking the end of the war. It took 2 atomic bombs to secure Japan's surrender, but after 6 years of brutal conflict, the countless men who had fought for their nations could finally return home. Japan's surrender marked the end of a dark chapter in history. The B-29 pilots and crews had fulfilled their duty for Uncle Sam, and now they flew not just for themselves, but for home. The promise had been kept, the hopes of many were realized, and for some, beneath the war-torn flag, a new promise awaited, the promise of peace.